In example 3, we want to solve for negative 90 is less than or equal to theta is less than or equal to 90. We've got the sine, so these are the principal values for sine. Great. One thing I'm noticing right now is we only have the sine. If that wasn't the case, we would normally want to switch some things out here and then try to get one trigonometric function only. Let me show you how this works if we let u equal the sine of theta. Here's what would happen. We'd have 2u squared plus u minus 1 is equal to 0. A nice little quadratic. And you know, I hope by now, that you need to factor this thing to be able to solve in this case. If this u wasn't here, well then we could just add 1 and divide by 2 and square root and we'd be good. But we do have this u here and that's going to be the problem for us. So let's see if we can factor this. We know that the first two terms need to be u. 2u times u is 2u squared, so the 2u here, the first two terms need to be 2u and u. And also what we need is we need to somehow get two numbers. When we multiply them we get negative 1, so it's going to be a positive 1 and negative 1. And then also when we FOIL this thing all out, back out, we need to get a positive u. Well, if I want positives, I want this 2u to be multiplied by a positive 1 and this negative 1 here to go here. And if you make a mistake here, just think about it. You know, do negative 1 times u and do 1 times 2u, and 2u minus u is 1u. If you switch these, you would have negative 2u and positive u, and then you'd wind up with a negative here in the middle. So we know this is the correct factorization. The next thing we would do is we would set each factor equal to 0. Solving there, we would add 1, then divide by 2. So we've got u to be 1/2. Or, in this case, we just subtract 1. U could be negative 1. Now over here on the right hand side, remember we introduced a variable. We let u equal sine of theta, and we want to solve this for theta. So we need to take the u out, and we need to keep that, or get that sine of theta back in by substituting back in. Or the sine of theta could be negative 1. We want to solve from negative 90 to 90, so let's be careful with this, and we want degrees in our final answer. So, let's see. 1/2 would be, I think 30 degrees has the sine of 1/2. You can reference your unit circle or your calculator if you need to here. So we're good there. The other one that has a sine of 1/2 is 150. So you should start thinking of these things, but realize that that's bigger than 90, so we don't need it. Also, right here, the sine of theta is negative 1. I think that's 270, but that's way outside the range. Let's subtract 360 and find a coterminal angle, and maybe that'll be here in this domain. So we've got 270 minus 360. That's negative 90, which actually is in the domain here for theta. So as our final answer, we want to list 30 degrees and negative 90 degrees. You can check your work fairly easily by just typing this in. So we can do 2, and let me make sure here when we're in going to need to be in degree mode. That's a gotcha. 2, and then we're going to need to take, we're going to need to take the sine of that angle 30, close and square here. Make sure to close them all off and square. And then we're going to need to add the sine of 30 minus 1. We should get 0 if we've done this correctly. There it is. There's the 0. When I check the other one, what I like to do is just do second enter button. So that's right here. And that gets your entry back in. And then I just cursor through. And then I'm going to insert here this negative symbol. And then make that negative 90. I'm going to cursor over anywhere where I see 30. We need that to be negative 90 now. And I think everything else looks good. We can hit enter, and you can see also that negative 90 solves this equation as well. The left side now is equal to the right side.